I guess I'll start. So if you recall, when I was sort of laying out long-termism, I pointed out that if we don't discount the future, or at least we do so only negligibly, or count future people for less just because they are in future generations, and if we buy those empirical premises about the way to do the most good in the short term being something like giving to the top give well charity, and there being the option to do a lot of good in the long term by contributing to asteroid monitoring efforts. And finally, if we think that given survival, the expected value, the expected utility of those future lives is at least as great as the present lives, which is itself positive, then any near best use of money, and probably at least some other resources, must be near best for the long term. So this was the kind of relatively rigorous argument for long-termism under sort of utilitarian moral assumptions. And then there were a few slides on how far you can deviate from those and come to the same conclusion. And then I went a little further and showed that, again, under those conditions, if some action or policy or whatever is near best for the long term, it must consist of either reducing existential risk or producing a improvement to the path of utility given survival that's not like asymptotically equivalent. Because the proportional utility gains you're getting as you get further out in time are getting smaller and smaller, and it turns out that as time goes to infinity, you prefer like any marginal reduction x risk to any marginal chance of going to the kind of non-asymptotically equivalent path. And we called those like real kind of changes to the path of utility trajectory changes. And importantly, there was a sort of background argument that unless stagnation or decline is on offer, a mere acceleration to growth that was going to happen anyway will be an asymptotically equivalent change to the utility path, because we're just kind of rising toward a ceiling that we're going to get to anyway a little bit faster. And we're just getting a kind of little crescent of extra utility in the short term that diminishes as we would have approached the ceiling regardless. And likewise, if in the optimistic case, if we're going to grow like cubically and as we expand in space or something, that'll still be sub-exponential in the argument we'll go through. Now, recall that when Bostrom was making his case for focusing on astronomical waste, he sort of seemed to think that number one, reducing X risk, was the only option for people concerned with the long-term future, right? Let's try and understand why he might have thought that. So he says, first, every second we delay colonizing the local supercluster foregoes all these like potential simulated human lives per second. Oh, and remember, I was pointing out how this argument relies on all three ways in which classical utilitarian ethics differs from that which we're familiar with in economics. It's counting simulated lives as just as good as real ones, so non-human, just computers that think they're human. Count for one. We're counting future experiences no less than present ones. We're not discounting, and we're really kind of valuing the larger population. But anyway, if you buy those assumptions, he's like, okay, for every second we delay, we're giving up 10 to the 29th potential human lives per second. So a single percentage point of X risk reduction would be worth a delay of over 10 million years. Seems the assumption he's making pretty clearly is that if we don't have an X risk, then we will max out on utilitarian value, right? Like, okay, so a way to visualize, I think, what the background assumption is that he was working with, and that, again, sort of got so many people to think that like to be utilitarian was to take your first four priorities as being X risk reduction. The assumption was basically that we have this very two-peaked distribution over possible values the future could take on. Either we'll have an existential risk, in which case, in the grand scheme of things, there's basically no value in the world. Or we'll get pretty close to the maximum possible value possible, where V max is just like maximal according to the classical utilitarian objective function, or something close enough that it makes no difference for this example. And if that were right, or if that is right, then basically, clearly, all that's left for us to do is move probability mass from the low hump to the high hump, if that's at all feasible, right? Yeah, if it's completely infeasible to change the probability of an existential catastrophe, then you can muddle around with the small potatoes of improving lives in a world that's going to end soon anyway, or that's going to be long. But the main project in this world is to move probability mass from the low hump to the high hump. But when you put it this explicitly, I'm not sure too many people would endorse it. Yeah.
Well, I just had a look at this for like 2 minutes, right? So my impression might be wrong, but the way I read this text was rather like him saying, "Oh, any probability distribution that is not completely peaked at the Dmax would be one where we want to work on reducing X risk before we like make progress. And once we are at the single one where we're completely centered on maximum probability of survival, then we can like keep going with technology." So to me, it seems like there would be like one out of many distributions talking about. But do you think that's not the case?
I do think that's not the case, but I'm not sure I understand what so you're saying maybe you think that we could wind up here, but just like the order of events, first we have to lower X risk and then we can move on. So raising the value of the future given survival.
Yeah, I think so. I think what you're saying, I guess what you're saying here is like you're saying, oh, Bostrom is implying this, but this is obviously a silly distribution. So who believes this?
Yeah.
And to me, it seems like maybe he's just saying, oh, any distribution we should move at anything that is on the left to the right, no matter what the distribution looks like.
But I mean, so what he's saying is we're foregoing every second we delay, we're foregoing that many lives per second.
Yeah.
Not like some distribution of possible lives, which is like, which has a mean in the middle.
Yeah.
Right. The way he gets to 10 to the 29 isn't by averaging over like the mediocre scenarios and the great scenarios. He's looking at the maximum computational capacity, right? The only way this is what we're actually foregoing per second of foregone technological development is if the probability, I mean, taken literally, it's if the probability is 100% that we're like at the Vmax that yes.
Yeah.
And then, there's been lots of discussion about this since then, and he does actually, you can find him like sort of blogging online saying that he does believe something like the two-peak view. But I think, yeah, certainly not like logically necessary that we're in this two-peak world. Yeah.
Like this follow from most utility being in the future?
Well, no, it doesn't follow from that. You could believe, I happen to believe, that most utility will be in the future, but like our uncertainty right now, or at least my own uncertainty right now, puts some weight on there being this much utility in the future, some weight on there being this much utility in the future.
Yes. Well, I guess it depends on what you mean by near best, right? I mean, if you're in that scale, then I don't know, right? But
well, the scale, I mean, it's not much of a scale. I'm just saying, like, there's some maximum, and like how close will we get to the maximum? And just buying, just on kind of a straightforward like Bostrom calculation, it's like, okay, there's this really high maximum if we went out and like figured out ways to turn all the energy of the stars into like running little computers that were really efficiently cranking out pleasurable experiences, and that's the maximum. And if I'm trying to maximize expected utility, and that's what utility is, and like turning half the stars into that just goes right here, whatever the units are.
Yeah, but my question is that if all you are assuming is that, right, so you're not discounting the future.
Yeah.
And so you have, right, roughly that there's an infinite utility in the future.
Well,
whatever happens now now.
No. There's a huge, the issue is that there's a huge, from our little standpoint on Earth, we can get confused. And that's what I'm taking issue with. We kind of look up at the stars and we think, oh, it's so vast, but like, if you're just maximizing expected utility all the way up, it's not like functionally infinite. Turning 10% of the stars out there into, bliss is basically nothing compared to what it could have been. It's just, we're almost, it's a tenth as good. Just like saving one person from being tortured here on Earth is not nearly as good as saving 10. Even from an ant's perspective, you think, oh, it's just so big, a whole person saved from torture. Yeah, so you might think, the option space is more wide open than that. You might think that, yeah, there's some chance of an existential catastrophe, and that gives it kind of an extra peak around zero. But given that we avoid that peak, things could be, things could be worse than zero, or things could be much better. The chance that things will be really utopian is pretty low, but maybe we can get pretty good. Like, I think this is also a possibility, at least. And so, if whatever is like the ideal outcome according to true morality isn't entirely inevitable, then maybe there's other work to do besides reducing extras, right? So yeah, again, the sort of somewhat tongue-in-cheek way of putting the ideal thing in sort of classical utilitarian terms would be tiling the universe with hedonium. And just seems like a tall order that's like inevitably going to happen in the absence of an existential catastrophe. So how might a non-asymptotically equivalent change to the utility path come about? So suppose one actor gets what's called a decisive strategic advantage in some of this literature, but where that actor doesn't have to be like a single state or a single company. It could be a coalition of people that have kind of bargained with each other, and they're working together to achieve some compromise objective. And suppose that it's equipment, its AI is so smart, its bots are so numerous, that, again, just as like people are with respect to animals on Earth, basically, we can just determine they can just determine the allocation of the world's resources, and the people outside the coalition can't stop them any more than the shrews can stop us from doing what we want to do. And recall how super exponential growth can make this more likely, at least if the model doesn't have those spillovers, right? So if like, you've got two entities that are, growing super exponentially, and maybe the laggard always has a constant, they're always behind by one period, either because it takes them a year to copy or steal the frontier group's tech, or because they're just kind of learning by doing, but they're always one step behind, and the path is super exponential, right? And that'll mean that the sort of gap in AK or whatever is growing and growing and growing over time. So people have argued from like different perspectives that one way or another, it seems pretty likely that this could permit lock-in, where the way that the whole kind of future of life on Earth, or Earth originating civilization goes, is in line with plans made by those with a decisive strategic advantage. To emphasize, I'm not at all claiming that like it's likely that you will get a group that has this property. I think super exponential growth can make it more likely when you think it through. But you could just have a sort of decentralized equilibrium where like no group ever gets this. But if a group got it, again, just as with people versus shrews, it seems like this could permit a kind of lock-in. So I said from different perspectives, people have kind of made this case. A positive case is made by Finbaden, Riedel, and Schulman from a few years ago, that actually worked through the mechanics of things like how error correcting codes are really cheap, for instance. So you might think, okay, if let's say we've got our bots now and they're trying to implement some really, really long-term plan over like 1 trillion years. Will it be really costly for them to keep their descendants in line, as they break down and get repaired and get rebuilt? And when you're, you have this issue whenever you're copying a computer file that it could get corrupted. And you lose a little bit of efficiency by adding some like checksums or whatever, some extra code to verify that the code was copied properly. And you're going to have to add a lot of that to maintain fidelity over like trillions of instances of copying. But it turns out it's not that much. Error correction is like pretty cheap. And and this is one example, but you can see kind of how you could dig into this and try to write a report about it and kind of make up your mind about it. And that's an example of some people doing that. There's a negative case, which is also sort of interesting, which starts with the observation that, Newton's first law or whatever, is that an object at rest tends to stay at rest, right? Just inertially. You have to ask, why is it the case that those with plans or those with power don't currently get to implement them indefinitely? And if you think that those, or at least a lot of those, will stop holding in a world with some group that has a decisive strategic advantage, like a global AI-enforced dictatorship or something, then maybe your just sort of default belief should be that its plans will be locked in. So, right now, concretely, what prevents power from being maintained? Well, dictators die, like a pretty large fraction of dictatorships end with the death of the dictator. And, a revolution only like bursting out when during the tumult that involves the transition of power. That will presumably be at least much less of an issue when you just have these bots with their plans kind of hard coded that can be copied in a way that a dictator can't copy his brain to a successor. Likewise, competitive pressure is a force that really, brings about the fall of empires and all of that. And at least in the absence of aliens, if you've got on Earth some group with a decisive strategic advantage, by definition, they have no competition, right? They've just outstripped them. They're outstripping them ever more. Yeah.
I'm not imagine size of trading advantage, but only if it adapt the institutions or norms like technology that's relevant for paving the world, I guess, colonial in this case, or whatever it is.
No. I'm not assuming they have that goal. They can have some other.
Whatever the word is, saying some way. I guess off Earth doing whatever paving the world, whatever the paving is, right? Whatever is advantageous to being able to whatever is efficiency maximizing in that setting. It could be the case that sure, the group will start out with their advantage, maintains that advantage, but only because they maintain the institutional norms technology, which is adaptive to the environment in which they're doing it. So yes, they're ahead, but they're only ahead because they're just dubbing in elevation selection. So they didn't get to pick ex ante which norms they like. They're ahead, but they're ahead because they're adapted to the setting in which they're.
But what do you mean by the setting? So if they're kind of just setting what happens to every atom in the world, at time zero, then what about the setting? Is an asteroid coming and changing the environment in a way that means that they've got to adapt their.
I'm thinking something say we start off on Earth, right, with some group with their decisive strategic advantage. Now, we're expanding out to space. It might be the case that the technology or norms or stations or whatever it is, or the preferences that are competitively advantageous in space, and it's different from the ones that are on Earth. So even if some group maintains the DSA in space, it has to be the ones which are consistent with what's adapted in space, not the norms that happen to like it set when I was dictating right now.
Okay, I see. So the change of setting here is the move to space.
Yeah.
Okay.
Yeah.
Okay, yeah. So different parts of the galaxy might kind of be adaptive to different sorts of institution. Yep, that is interesting. I mean, you're still going to think that the people who have all the power at the beginning, unless they're just mismodeling what's coming up with the environments, they're going to be getting the best that they can under that constraint. Under the constraint that their descendants are going to be, Wait, no, but I still don't really get it. So what are you saying here? Because it's not like competition is going to show up once they get to some other. Again, assuming there's no aliens, once they get to the other side of the galaxy, The environment's different. Maybe they're not going to like, they would be able to outcompete some invaders that had some like different institutions that were more adaptive to that part of the galaxy, but there are no invaders.
Well, I guess, why not? I guess.
Well, why not? Because I'm just.
Like, the other human group which wasn't.
Well, because, okay, so they don't want that to happen, presumably. So yeah. Yeah, you know, right now, kind of, you'll have a, you know, maybe a popular uprising that installs a dictator, but they change their minds, or either because, you know, they just, yeah, they learn more, or if this dictatorship doesn't work out as planned, they could rebel. But like, we're just stipulating that we're starting out with a group that can really just fully control the allocation of resources around the world, and presumably that'll be even less effective maybe than like a rebellion of shrews against humanity would be today. And yeah, more kind of to your point, Karan, new tech can be really disruptive, and it could be that you just, you know, it's worthwhile for a group, you know, fully in control to like roll the dice over and over again. Kind of like in one of these Chad Jones models or something, where like we like technological development, even though maybe at every step it comes with some chance of an existential catastrophe. Maybe for them, they like technological development, even though with every step, that, you know, they don't know exactly how it will unfold, and it comes with some chance of uprooting themselves, right? And I think this is a good argument. And then this will eventually peter out once you get to like technological maturity. So at least if you have DSA and technological maturity, it seems especially hard to see what could like upset the great, you know, the great lock-in. This is as you've probably figured out, this is by far the weirdest presentation, and I hope we can have fun with it. Yes, Maxim.
Maybe but is there some hope for an AI that is sort of similar or smarter than human intelligence to exhibit the same kind of problems, you know, like, I don't know, in the sense, you know, it might develop some sort of mental illness, or, you know, like some sort of hope that,
what a hope.
kind of like intelligence inherently comes with faults that can be exploited, right? Yeah, I don't know.
I suppose you could hope that. Maybe, I mean, if it's bad enough that it's exploitable, I want to say that they don't have a decisive strategic advantage. Yeah.
I mean, what makes Gaston's whole point then is kind of, oh, we gotta improve institutions before lock-in, right?
Yeah.
That doesn't seem.
Or values.
Yeah, true. That doesn't seem very easy.
No. But it's happened before. The improvement of institutions. So, oh, you mean it doesn't seem easy because we don't have enough time?
No, I mean, like, I really like this essay, but I think it seems like a thing that in the past happens.
But institutions have already been locked in.
Very specific environments that I think that are hard to deliberately bring about.
Coordination, right? It's like super hard to agree that everybody should not develop the strategic advantage, right?
I don't know. You can also read it in like the whole, like, the whole Asimov's lens of this and so on, right? And I think Troy might make a very interesting point, right? Like these bad institutions we pay and so on, but he's never been able to like come up with a way to tell us how we get through these expenses. I mean, obviously not. It would be his whole point instead of that.
I mean, briefly, one thing that Will, but also yeah, with like Aaron Ballender and some other people a few years ago thought about is this point that like maybe, yeah, institutions are only plastic, only able to be changed during brief moments of instability or something, right? You know, the moment is just right for, you know, either, you know, there's like a revolution, or it's just after some war and we're writing a new constitution, or whatever. I mean, it's hard to predict these things by nature, but yeah, in a way, that's like an optimistic story for transformative AI being really disruptive. It means that maybe the thing to do in advance is just have all these plans on the shelf, right? To, implement it when the time's right. Even though right now we can't do anything directly, we can do one thing, which is plan. All right, well, let's call flourishing getting within, say, 50% of that Vmax. So given advanced AI, how might we respond to Bostrom? Why isn't flourishing just inevitable? Broadly speaking, I think you can sort of fully taxonomize it as being either because of a coordination failure or a moral failure. So coordination failure being no one gets to like have plans and like have a utility function that they just implement going forward. And so we end up in an equilibrium that is not on the Pareto frontier of what people would have wanted, like for any bargaining weights to begin with. So Guy Vasadi has this essay from 2 years ago about how, we might expect in the long run, absent really strong coordination, to wind up in some sort of Malthusian equilibrium again, where maybe the robots are all kind of growing in, according to that Malthusian logic, but now they're not constrained that we can like skim all the consumption off the top and have hyperbolic consumption growth. But actually, they're just, competing all the potential surplus away in reproduction, just as, animals do in the wild and people maybe did in the past. And there's, I think, a sort of interesting econ paper by Ely and Shentes from last year, which sort of goes through that logic in a more kind of formal model. And unfortunately, yeah, I put all this work into understanding how the model worked, and I thought I might get into it here, but then I figured I'd just shorten the whole presentation because there's going to be 2 presentations, and now it's like barely one. But yeah, you can check it out if you're interested. But hopefully the logic's like sort of clear, right? Like if we don't prevent the machines or whatever that get some sort of mutation that motivates them to reproduce as quickly as possible and eat up all the potential resources. Like if we don't contain that process, then we can just sort of wind back up in a state of kind of nature as it obtained in the past. So that would be a coordination failure. And then the other possibility would be that we do get like plans that just get implemented without being subjected to competitive pressure. But few or no members of that coalition with the decisive strategic advantage even want a good future. And so the point that we land on the Pareto frontier is way less than Vmax for like the true V function. I mean, I think in practice, certainly if you're a classical utilitarian, you think like, okay, most people don't want a future that looks very good. Like, going back to the graph, like, I mean, like if you just put it to a vote now, like among world leaders, among billionaires, among just the average person, among whoever, like what population would vote for all these simulations as opposed to something that looks more natural and human, where like, everyone gets their own planet and it, but everyone getting their own planet and sort of flying around in a spaceship, I mean, that's like there, and hopefully, the general point can be, it's like, I don't mean to like try to, impose my particular moral beliefs on the impressionable youth, but like the general point I think should be clear enough. Like people in the past believed all sorts of things that we now consider immoral. Morality might just be strange, and so yeah, we shouldn't take it for granted that even if plans are implemented, that they're anything like moral plans. On the other hand, you might worry that flourishing is hopeless, right? That the best we can hope for is saving a very, very low value world because we'll sort of inevitably compete all the value away or something. And there are at least some arguments I think are worth chewing on for why that might be a bit too pessimistic. So first, again, we're thinking about a world of advanced AI. We don't know what that'll look like. But I think it's entirely plausible that it will allow for greatly improved coordination, partly because of the ability to commit, though Max showed us that this is ambiguous. Commitment can actually kind of worsen our ability to coordinate sometimes. But that's not necessarily right. And it could turn out that we're in a lucky scenario in which the fact that we can that we can commit means that we can coordinate better because for all the usual reasons, right? Like you know that I'll pay back my debts and so on. And even when it would be very costly to enforce some kind of commitment, if we're kind of making different plans throughout the world or even expanding into space, a bargain that we made on Earth, we will kind of all live by because we can kind of, we can just mechanically commit to it. Another channel through which sort of a world of advanced AI might have more coordination is through monitoring. So how many of us are familiar with the Folk theorem? So I'm seeing like maybe half. But so briefly, there's a result that people notice for a long time when thinking through the logic of repeated games or dynamic games more generally, which is that there seems to be a lot of equilibria. And some people had some intuitions about a general result, which has been proven in certain narrow circumstances, various ways. But the kind of general point that in a large class of dynamic games, including all repeated games, the set of equilibrium payoff profiles expands to the set of feasible and individually rational payoff profiles as the discount rates go to 0, where the monitoring goes to perfect. So the idea is I don't know, but you know how in the prisoner's dilemma, there's like the repeated prisoner's dilemma, and we can all coordinate because if anyone defects, then we all switch over to the defection equilibrium going forward. And that means that we can get a bit more coordination. That'll only work if people's discount rates are low enough, right? So if people discount each future period, like almost 100%, then you don't get the coordination equilibrium in the prisoner's dilemma, because it's sort of everyone's just kind of acting like that one interaction is the only interaction they'll have. They discount the future almost completely. But for a constant discount rate, you can effectively lower the discount for constant actual discount rate, you can lower the effective discount rate by just shortening the length between periods. If we observe each other's action every half year instead of every year, then I'm only getting away with 6 months worth of defection before I'm hit with the whammy of the bad equilibrium, right? And so it's as if I was discounting the future half as much. And as the monitoring gets ever more perfect, like in the case of instantaneous monitoring, if I try to defect, I only get to enjoy the defection for 1 second, right? And then basically I'm just shooting myself in the foot immediately. And AI seems like it could be especially good at monitoring, right? People are concretely trying to improve our coordination with China, or like labs coordination with each other by building, chips with like zero knowledge proof mechanisms where will like monitor exactly what you're doing. And if you're doing something illegal, then without revealing concretely what you're doing, it'll be able to detect you're doing something that checks the box of breaking some rule and then kind of notifying the other party instantaneously. So better monitoring, not in the abstract, very concretely can improve coordination. Just like, so that was a very complex and like high-tech example of improved coordination with more advanced technology. A much simpler kind of thought experiment is just like, over time, as our technological capacities have grown, have property rights gotten more, like better preserved or worse? And I think on the whole, it's got to be better. I mean, just, highway robbery in the Middle Ages or something was happened all the time, and now more or less we're secure in our property. And if that process just sort of continues, and then we'll kind of be locking in ever more property rights, and kind of the horizon on which we can reliably make plans with the property we currently have will continue to expand. Actually, incidentally, this sort of ties into a graph that Zach put up before on like interest rates declining over time, and it's hard to pick out the risk-free interest rates from the actual interest rate, because we've been getting better and better over time at getting paid back. So space governance is currently very up in the air. Property rights in space are not allocated at all. There's this UN charter on space governance. I forget what it's called, but it sort of just has some vague language about matter outside the atmosphere being like the common heritage of mankind or something. But maybe how that gets precisified could be a channel through which we kind of actually just coordinate in a very recognizable way. Okay, so I was saying, yeah, flourishing might not be inevitable because of coordination failure and/or moral failure, and this is pretty exhaustive. Seems like there are at least some channels for thinking that like really advanced AI might improve coordination, improve flourishing that way. There's been a bunch of sort of philosophy papers summarized on that Wikipedia page on AI improving our moral reflection, and sort of some case studies of like people updating their beliefs about moral questions sort of more quickly with interaction with AI than via other means. So maybe somehow it'll speed up the process of moral reflection. But then finally, a way that it might not be so hopeless that we get to some like non-negligible fraction of V max, even if not that many people are moral, is that the Pareto frontier may just allow for a few morally motivated actors to achieve most value. Okay, so like, for example, let's say, again, this is just for an illustration, I'm not saying you've all got to be classical utilitarian, but if that's a true moral theory, and most people want the sort of what I'll call the liberal space opera, meaning like liberal and like we all get our own planet and sort of, normal norms are respected and everything. And that seems like utopia to common sense morality. Well, there's kind of a nearly complete win-win where like you preserve, say, the solar system for, human life in abundance or something. And then like the rest of the cosmic endowment is turned into the thing that's weird, but actually ideal, right? Kind of like on Earth, most of the Earth is sort of put to good human use, but then we have a few like managed wildlife preserves out there. That's kind of what the solar system would be, with normal humans being the wildlife.
Bill,
yeah.
Since we're listing things on like improved coordination, I think a classic econ example of coordination is a bad thing, but like collusion in markets, right? So like improved monitoring is bad for that reason. The folk theorem gives us bad outcomes in market settings and so on.
Well, but that's so I would say that's coordination among a subset of people, kind of at the expense of the consumers. Antitrust is just even more coordination, right? It's all the consumers getting together and all the businessmen and like electing people to like or organize markets in an efficient way. So yeah, it's certainly not like completely monotonic, where just improving coordination like among the Nazis makes the world a better place. Like no, like if they're ganging up on some other people, that can be bad.
There's not really coordination if one of the parties is made worse off. Like coordination of others. So like the monopolist is made worse off in the world in which you make the markets competitive, even if it raises total output. Monopolist is still sad.
Well, no, sorry, I see what you're saying, but for the and it's a good point, but for these purposes it would count, because we're failing to coordinate, not insofar as we're failing to like improve everyone's well-being relative to some bargaining point or whatever. We're failing to coordinate insofar as we're not implementing like a coherent plan, like a coherent utility function. whatever that is. So I would just separate like whether we're coordinated in that sense, whether we have a social planner at all, regardless of whether they're throwing a monopolist under the bus. And then that's like condition 1. And condition 2 is like what they're going for is good. All right, well, as we've seen, there's another kind of hidden assumption in Bostrom's case for astronomical value from X-risk reduction, right? The first I've been harping on is that given that we save the world, it'll be good. But the second is that given that we save the world, it'll stay saved. Carl Sagan called this hypothesis the time of perils hypothesis, that X risk is high now, we can lower it now, but once we save the world, risk will stay low. And we talked about some reasons, why you might believe that or not. And in depth, of course, yesterday afternoon, the kind of existential risk Kuznets curve could be one reason to believe this, in which case, saving the world kind of gives you a long future and expectation. But there's another argument, kind of in a similar spirit, that this is an important time. This is a time that gives us unusually much leverage over the future, or a technological landscape that gives us unusual leverage over the future, not because we could fail or succeed in saving the world, but because we are finally at the point that we have a lot of power over nature, but our descendants are part of nature, and so our descendants won't have power over themselves. So the idea here is like our influence over the future is sort of following a bell curve one way or the other. Before we can save the world, we can't have much impact on the world via lowering X risk, and then there's a time of perils. Those people are really important because they can, the ball's in their hands. And likewise, before we can modify nature very much, history is just kind of taking its course. And then we kind of coordinate ever more, and we kind of get ever more control over nature. But then we lock in, and kind of everything falls according to the plans of that one dominant age, as C.S. Lewis put it in 1943, the abolition of man. He said, let's suppose there's one age of the 100th century AD, which resists all previous ages most successfully and dominates all subsequent ages most irresistibly, and thus is the real master of the human species. Man's conquest of nature is a power over man as well, and every victory, besides being the general who triumphs, he is also the prisoner who follows the triumphal car. So it's very poetic, but you get the idea. It's like there's a bell curve and the peak is 100, yeah, 1000 AD. 10,000 AD. And then kind of putting these two thoughts together, Parfit in 2011 in the second volume of On What Matters said, well, via one way or the other, it looks like we might be at this sort of special time, which he called the hinge of history. Okay, so this has just been a huge elaboration on kind of two of those three. I had that taxonomy before when kind of outlining long-termism. I had the growth, the X risk, and the trajectory change. This is trajectory change in the abstract. And it's 3 o'clock, so let's break for 15 minutes, and I'll kind of share a few thoughts on how to compare the case for working on survival versus the case for working on flourishing. All right, thank you. All right, just 45 more minutes of me being a little eccentric, and then y'all can go home. So, yeah, so we're trying to make up our minds about sort of whether we should think that working on those trajectory changes, those non-asymptotically equivalent changes to the utility path, are more promising, or working on reducing X risk is more promising. And we had that little baby step of a heuristic, which is that, if you buy those Graves and McCaskill assumptions, you can just think about impacts on the long term. And so you can say the expected utility of the long term is a probability that we make it there times the expected value given survival. This is just a little factorization. Again, of course, we're setting, zero. We're just defining zero utility to be what happens if there's an existential catastrophe. Bless you. So let F for like degree of flourishing, the expected utility of the long-term given survival. And so increasing each factor has by the same percentage has the same impact on the thing we care about, expected utility of the long term. And you know, we went through like some broad ways that you could try to improve the long term, like by improving global coordination or improving people's values. But just like very a priori, here are 2 reasons to think that working on the F factor is more promising. And if you actually want to make up your mind about this, obviously you should just kind of like think concretely about what the options are in each category. But the first observation is that we're probably just much nearer the ceiling on P than on F. Unless you're really pessimistic about near-term X risk, P is not that far from 1 already, and 1's as high as it can get. So like Toby Ord 2020, in 2020 in the precipice, you know, I think to a lot of people, he seems especially pessimistic. Obviously, he's not like as doomer as you can get by any means, but he thinks there's a 1 in 6 chance that everyone will die within 100 years, basically. That means we're 0.83, we're 83% of the way to the absolute maximum on P, right? Yeah.
When you do like a calculation like that, do you also include something like there might be like a subset, so like a subgroup of the human population that become transhuman and destroys the rest of the population, or not really?
I mean, if they're having a good time, I would count that as survival, because existential capacity is a zero use. But I mean, the calculation is going to look different on different moral views. So if you have a view where like sadistic transhumanist pleasure doesn't count, then maybe that's a 0, and then that is an existential capacity. Does that make sense?
For sure.
Great. By contrast, unless we're very optimistic about how close we are to V max, right? So for instance, unless we think that, say, like true morality is very similar to current 2025 human common sense or something, it seems like F is very far from its theoretical ceiling on the business as usual. That's kind of what I was saying before about the space opera looking like it's kind of practically a 0. So just kind of on this importance front, like how much better does the world get if we solve the problem that the factor is not at its maximum? The second factor is probably the more important one. And on the neglectedness front, likewise, most people already have really high willingness to pay not to die. And as Chad was telling us yesterday, yeah, it seems like maybe we're underinvesting, even like, you know, maybe just add it up, everyone's willingness to pay, so lower existential risk, it would be more than we're currently spending. And that suggests that some enterprising politician will figure that out before too long and actually implement more spending on safety or whatever. Schulman and Thornley have a calculation that's very similar, which I think is also worth checking out if you want to make up your mind about that question. But anyway, that means that like this project of raising P is probably either like currently less neglected or will soon be much less neglected. And again, presumably that's much less true for F. Like people's willingness to pay to create some like, you know, like a zillion happy simulated minds in 1 trillion years in some other part of the galaxy is, I mean, mine would be really high, but you know, if we add it up across the population, it's probably low. Now, neglectedness here, normally when we're thinking about what cause to work on, neglectedness is a plus, right? Not many other people are working on it, means there's a lot of low-hanging fruit. In this case, it could actually be a challenge insofar as some people actually want lower F, right? If there's a tension between whether the resources, like the cosmic endowment, as Boston would call it, gets used for good or for common sense. But here, that could be less of an issue if you have that sort of near rectangular Pareto frontier, right? That I was kind of gesturing at before, where with very little sacrifice on like some views, you can get huge gains according to others. You know, like the preserving the solar system as like the wild the wildlife preserve or whatever. So I'm not saying anything about tractability. If you're familiar with this sort of factorization, there's a way of breaking out expected utility into the product of some definition of importance, neglectedness, and tractability. And all I'll have to say about tractability really is kind of the vague thoughts of the previous section, but I think we can say at least a little bit more about importance and neglectedness at least. So this is a very high level overview. You just kind of got these two factors, and increasing each one is equally good. There are two adjustments to this argument that you might want to make, and I think there are many adjustments, but two that stand out as especially big to my mind both end up pushing in the direction of focusing on flourishing rather than surviving, or at least kind of nudging you toward thinking that a priori you should think flourishing is more promising. The first is that when you save the world, you're not actually saving a world at random necessarily. So conditioning on the fact that you saved the world, the expected utility is not your all things considered expected utility given survival. It's only that equality only holds if the fact that you've successfully averted that X risk gives you no information about how good the future will be. For an example of how this could fail, let's say you've got two hypotheses about human nature, one of which says that fundamentally we're peaceful deep down and we're capable of creating institutions that will work together peacefully and create a great future. And the other hypothesis is that we're violent deep down and everything we do is broken, and all of our attempts to coordinate will ultimately collapse and result in outbreaks of horrible torture now and then, which make F not just low, but negative. So the value of the future is negative. It would be better not to exist than to have a future that will implement in this scenario. Okay, you might think that F is really high in this scenario, only a little negative in this scenario, and this scenario is much more likely. And so all things considered, your expected utility given survival is positive. You just learn that we're going to survive. You think, okay, good. But preventing X risk from more could disproportionately save us in the cases where F was negative, right? If we have all these nukes lying around, we don't know if it's if we have it in us ever to launch them, and then you disarm. Well, it could be that we only would have launched them in the F negative worlds. So the nukes were functioning like a fuse box, which would have just kind of cut off the utility of the world at zero if it was ever going to go negative. Because we blow ourselves up instead of surviving in a way that's horrible. Now, in principle, this can work either way. And one way in which you could be disproportionately saving a valuable world is if we have uncertainty about how powerful AI can get. So let's say we don't know what the ultimate ceiling is on compute efficiency. And so, how big the software intelligence explosion is depends on that ceiling, if you remember from Tom Holden and Tom Davidson that was on software. And we don't know whether that ceiling is here or here. And we're currently here. Right? Then if it turns out the ceiling is really low, the future won't get that good because even if we turn all the stars into donium, that's just we're getting less we're getting half as much value per unit of resources as we are in this case. But in this case, you get this period in which there's a lot more existential risk because the world is moving really fast for a much longer period of time and it's more destabilizing. Right. So this would be a case in which if you save the world, if you try to save the world, you're more likely to be saving it in the case where it's riskier, which is this one. But that's a world that's more worth saving. I think on balance, the first sort of kind of case seems more likely to me. It especially seems more likely when you realize that if what you mean by an existential catastrophe is just an outcome that's like basically around zero value, then most of the ways in which you're going to be sort of shifting probability mass away from this peak, you might just think, well, it's, in general, it'll be easier to turn a distribution that looks like this into one that looks like this with mass just shifted to the right a little bit than one that's transformed in a way that, like, you know, creates a bump way out here. You're like a world that was just teetering on the brink. If you just save it, if you just save a patient or something, then they're probably going to be less healthy than someone who never needed your help to begin with. Anyway, that's kind of one category of adjustment you might want to make in one direction or the other. And the other one, for Karan's own enjoyment, is what about the aliens? So the whole kind of calculation that the expected value of the future was just probability of survival times value of survival didn't have any aliens in it. And let's say we're starting out here on Earth now, and this is like the light cone, so over time we're occupying a floor space or whatever. Okay. So without any aliens, you're just, you know, increasing the value that we implement by 1% is, you know, it has the same impact on expected utility as increasing the probability we get this at all instead of just sort of nifty civilization. But now let's say you've got some other planet out there, you know, a billion light years away, that's got some aliens on it, and they're also expanding, right? So now, oh, and let's say there's like a 50-50 chance when we encounter them that we win and they win, and maybe we just, you know, we coordinate, we split the resources, you know, 50-50 when we encounter them. Now, if you assume that they're no better or worse than we are in expectation, then the value you're creating by saving the world is just this like extra edge of that, you know, cone of influence or whatever. Doesn't only the light cone if we're actually looking to see it well, but you can see that we're only getting this because like all of these resources would have been put to good use by the aliens anyway, or use as good as we're going to put it. Whereas trajectory change is getting you an improvement, not just to this, but to something like this, right? Because you're actually, you know, you might be replacing the alien civilization with one that's like a little bit better. And there's a kind of interesting analogy to the winner's curse here, which like the thing I wrote with Will on this doesn't really get into, but the thought is, let's say, you know, there's these different civilizations and you and the aliens each have like a budget, as it were, to allocate between moral improvement and just increasing the probability that you survive. Well, the chance that you survive then is like evidence against you having invested more in moral improvement. So it's a you only even want to be displacing the aliens if you kind of disproportionately worked on flourishing. Anyway, but you don't need to go there to just understand this point, how it just changes the factorization and ends up kind of meaning that a % increase in flourishing is more important than a % increase in X-risk reduction. Does that satisfy your itch for aliens? It doesn't fully get into the question of like adaptiveness of like different values and institutions, but it kind of does with the winner's curse point. Yeah. All right. Again, I know how weird this is. I just, you know, I think it's important. Oh, great. Yeah.
I guess like the most practical takeaway would be something like maybe we should not care that much about, or like we should push the AI ways because, you know, that's like could be a tremendous flourishing, or like booster for flourishing, right? And
yeah, I mean, but you know, I think the idea that we have to race would be a failure of coordination. Like maybe right now, that's the best we've got. But I think we should hold out hope for, AI kind of either through better monitoring or whatever it is, better commitment, making it the case that we get on some kind of creative frontier and we're kind of, coordinating.
I feel like my point, because I mean, even if we just kind of spend more on mitigating the risk, I think it's pretty clear that AI will eventually I think it's pretty likely that AI will arrive anyways, right? The development will not completely stall. And so then you're not a trajectory change, right? As you said, like it's all the same, right? Like, but I wouldn't even go, what would be like really a trajectory change? It must be something that's past, unless you believe that there's a huge risk that we actually like stall AI development forever.
Yeah, I mean, I don't think that's a high risk, but who knows? But I think of the more likely sort of trajectory change is one in which we kind of set AI off doing one thing versus another, like implementing the space opera future or the hedonium futurism. And then, Will was thinking about this, like, to what extent does it seem like there have been like moral trajectory changes in the past? And so he has this book, What We Owe the Future, in which he argues that there have been some. For instance, that maybe, I mean, to this day, I think like half the world's vegetarians are in India or something, and like a large fraction of the population vegetarian. That's sort of the holdover from religious kind of developments a long time ago. But what that would suggest is that the fact that Christian derived like Western civilization ended up colonizing most of the world instead of it being like India probably means that there are like many, many billions more animals being killed every year now, and that's just sort of a persistent immoral trajectory change from his perspective. I would agree. And then, but going the other way, the fact that like there was this somewhat idiosyncratic movement to abolish slavery in Britain, the fact that they were really successful colonizers really hastened and maybe actually just brought about the end of slavery that otherwise wouldn't have happened, and we would all be either slaves or slavers now otherwise. So I mean, people really contest these examples, but yeah, it would be about that rather than just about like speeding or slowing some technology that's coming anyway. Yeah, that's okay.
Just to question that we were posing on two about the world that we're saving.
Oh, this one, adjustment one. Yeah.
Just one, sorry. Yeah. I was thinking about your second bullet point. I was wondering, like, I guess this is just like an example, right? Because I could think about like individual agents that just like exist in society that are horrible and that could cause an X risk. And the fact that like I prevented that kind of like action does not necessarily mean that society is gonna be bad for the future.
No. It certainly doesn't necessarily mean it. This is a really stylized example. I'm just trying to illustrate the like statistical point that you could have two hypotheses which are correlated with the value of the future. I'm not at all wedded to this being realistic.
I was like, maybe that's too philosophical, but like, if we think about ourselves, maybe we would not like violent world, but like, if the future looks like Mad Max and there are these guys that actually like that kind of behavior,
yeah,
they actually might, what we think is F is negative, it can actually be F positive for them.
I agree. No, that's perfectly, that's a good point. Yeah. But I'm gonna stipulate that I mean actually negative F. Like it's just, you can have a probability distribution where it's like conditional on the fact that I saved the world. Actual F is negative, but it's always hard to know what F actually is. Yeah.
Adjustment. Maybe this tax is adjustment one little. if we have some like evidential reasoning around these areas of space that we care about, does this it feels like the logic changes quite a bit. But like
Yeah,
if
that's
after
true.
you survive implies that you think it's more likely the alternative civilization also survives.
Yeah, exactly.
Yeah.
That does change.
Okay, cool.
I mean, also it's, yeah. Well, it changes things, but they might change in a way that cancels out. I have to think about it.
Yeah,
It's all more
the part when you
because-
feel about it seems like as I was trying to get through.
Yeah.
It's messy.
I mean, with these like evidential cooperation things, it's always really sensitive to your prior, and maybe here there's a simple prior to just, you're just like the aliens, but because in principle you could have any prior, right? Like you could update on the fact that you went for flourishing to think that the aliens didn't or something. All right. Somewhat changing tax, but we'll tie it together a little. As Zach has shown us, for most purposes, if we think that the possibility of near-term TAI is really underappreciated, we should probably want to spend more quickly than otherwise. Like the way he put it was interest rates should be higher than otherwise. But given that they're not higher, it's like, okay, well, if with these beliefs you would need really high interest rates to compensate you for delayed spending, then given that in fact they're low, I should probably not want to delay my spending because I'm not getting those high interest rates, right? I should spend a lot now. And he wasn't thinking about like long-termist grounds really. He was, but if Parfit's right about there being a hinge of history right around now, one way or the other, then that's going to be true for the long-termists as well. Now, it might not be true on any particular little horizon. Like maybe you think the real hinge of history is coming in 20 years, and so you want to save a lot now for 20 years. But like in the grand scheme of things, you want to spend when you can turn the hinge. On the other hand, though, if the channel by which lock-in is ultimately achievable is that long-term secure property rights point, right? If we kind of just, end up having totally secure property rights and we get all the gains from trade, but we, how those are allocated, it's just kind of the extrapolation of how people accumulate resources today. The long-term saving today can be very valuable, right? You're actually like changing how many of the stars get turned into hedonium or whatever. And to put some numbers on that, currently there are 100 million stars in the accessible universe per dollar of global net worth. So there's a fun fact. If you just preserve your fraction of global wealth, right, to the time when we're like accessing the stars, if that ever happens, and if we access all of the accessible stars and all of that, then that's what you're losing with every dollar is like 100 million stars. And you might think that you can really increase your fraction of global wealth by sort of taking advantage of that whole inequality dynamic that seemed like such a bad thing when we were thinking about the Gini coefficient, which is that in an AK world with high A, small differences in savings rates can produce really big differences in growth rates, right? They compound, those differences compound really fast. So you just save everything in a world of explosive growth, and by the end of the growth explosion, if no one else was saving everything, then you've got like 99% of the wealth. You might worry that in a world with such rapid growth, we'd basically inevitably be expropriated. There'd be so much turmoil. I think that's a risk, but it's worth noting that maybe the more relevant question, at least when comparing this plan to the plan of just like investing for like a zillion years till you get the 100 million stars, if you make it till there. The question is whether we compress the sort of millennium or whatever of expropriation more or less than the millennium of growth. You see what I'm saying? So like maybe we get really fast growth, and on the business as usual path, it would have taken us a millennium to grow that much. And the question is like, is the probability of expropriation more or less than you would have thought it was in a business as usual world over 1,000 years? And so, even if the probability is pretty high, I think it can still be less than that. Can still sort of seem like a reasonable proposition. And then, yeah, finally recall this point that there might be this, this really concave Pareto frontier where the first few dollars being allocated or, put into some bargaining problem for some unusual values to be really valuable. So, if the Pareto frontier looks almost rectangular, if it's like this, then, if this person has all the wealth, then you might get sort of something almost worthless to you. But with like the first few, sorry, what am I trying to say? If you've got this much wealth and they've got this much, so this is the bargaining point, right? What maximizes the area. So if you're Nash bargaining, you kind of find a point on the frontier that maximizes the product, right? And that could be like out here. So you get like almost all the value by having the first move up. It's like you're buying some distant galaxies that no one else was bidding on, basically. So putting aside how much to set aside for, that like lower inodic condition reason for like putting something aside for the long-term future, this investment problem is kind of like the question of how you invest when we're just dividing a large fixed pie. Because in the very long term, the marginal product of capital has to be falling to zero because like the feasible growth is going to be sub-exponential. It'll be cubic. And so you might ask, okay, what changes about investment strategy if we're just trying to sort of maximize our long-term share of a fixed pie that everyone else is also growing toward eating up? All sorts of things might change about our optimal investment strategy if we actually have these beliefs. So we're going to get like hyperbolic growth soon or whatever. You want to like buy more NVIDIA or something. But putting that aside, just like from first principles, what changes? Now, ironically, in a previous version of a program like this, I had a whole bunch of slides mocking the overuse of this formula called the Kelly rule. And this is sort of going to be one of the cases in which you want to use it. But I think not exactly. So yeah, so suppose you want to maximize your expected fraction of the pie. So you just care about your expected fraction because you'll put the resources to what you think are good uses. You think other people will just waste them, and there's no room for gains from trades. This would be a world with like a linear utility possibility fund. No gains from trade at all. There's just this fixed cosmic endowment, and you just want to have more of it, and you want someone else to have less of it. And suppose that there's some stretch before the pie is going to be divided, during which you face a sequence of gambles between, riskier, higher expected return investments and safer, lower expected return ones. We'll say that those investment opportunities are the same for many, many periods before the game ends, and then we divide the pie in proportion to the wealth that we had at the end. So the wealth isn't really real wealth because you're just dividing a fixed pie proportionally according to the wealth that everyone had in the interim. But in units of currency, before we've kind of remembered that we're just dividing that fixed pie, you grow your endowment exponentially at best, because we'll just say you have the same investment opportunities across all the periods. And maybe the growth rate can be really, really high, but it's just constant over time. So we just transition from like current to like really, really high growth, then like no growth fixed pie. So what do you do during that period to maximize your expected fraction of the total wealth at the end, given those assumptions, given that everyone has the same investment opportunities? Yeah, that's the long end, yeah. You're going to want to maximize your expected long-term growth rate, basically. And it, given for any finite t, that won't exactly be right, but it does actually converge to that. And this is equivalent to maximizing your expected growth rate at every step. So at every t, maximizing the expected growth rate, the expected log ratio of wealth in the next period to wealth in the current period, which will just be maximizing expected log wealth in the next period because WT is fixed as of t. So you're acting as if you care about your absolute wealth at the end, but have log utility. So this is sometimes called the Kelly rule. And Paul Cristiano points this out and draws the connection to like this problem, basically. And for intuition, although you actually care linearly about how much of the pie you get because of that, like, linear Pareto frontier, high payoffs from the risky bets sort of count for less because they occur in scenarios in which the others who also have the same investment opportunities are also richer because your bets pay off when they also pay off, and then your payoff has less of an impact on your share of the pie. Something like that. But I think the linear Pareto frontier assumption is really pessimistic. And again, I think, kind of a big part of the motivation for trying to invest something for the very long term at all is that it seems like, at least, I don't know, to me, it seems from first principles like there should be these really big gains from trade. And, intuitively enough, you want to be more risk averse. So my kind of, again, hopefully kind of fun stylized example here is, let's say there's two people here, an EB, an eccentric billionaire who wants to tile the universe with monuments to himself. The EA wants to tile it with hedonium, classic. And there's gains from trade where you can tile the universe with, something that's like slightly energy inefficient, simulations of EB having a good time. Okay. So like we can gain from trade there. And given that the resource distribution starts out like this, we're going to Nash bargain, we're going to maximize the product of utility gains. And your coefficient of relative risk aversion in the fraction of the pie itself, the thing that was 0 in the linear utility frontier case, ends up looking kind of like this. So, it adds another half or so until you end up getting really rich, in which case it turns out that it skyrockets. But so I'm hand waving, but you sort of add them together. So you get it sort of, you should act like you're more risk averse. Like maybe you have a coefficient of relative risk aversion of like 1.5. In this case where it's not even like nearly rectangular, but you just have this like circular possibility. Sorry, I should have spelled that out, but this is under the assumption of a precisely circular utility possibilities, for instance. Anyway, the very last thought I'd throw out there, just because I don't know who else is going to think about it, and you can all chew on it as you go home, is the following. So we've noted that production as a whole already increases some modest increasing returns to scale due to specialization, right? If you're considering all the natural resources and everything. And we've discussed a few ways that advanced AI could increase the degree of increasing returns to scale by more tightly integrating different like units of production. So you get more spillovers between different machines performing tasks and sort of learning from each other, or like, having one big brain instead of lots of little brains with low latency and all that. So something I've sort of been musing about is what changes if increasing returns to scale ultimately holds sort of all the way up, that as civilization and, our kind of AI successors get ever more interconnected and, that like, yeah, one big brain, one big bot counts for more than two little ones. What if one whole Jupiter brain even is much more valuable than two half Jupiter brains, say? So for starters, there'll be no such thing as hedonium in this world, right? Hedonium is like a simple structure that you can tile the universe with. You can have the same simple little chip over and over again, and then you crank out, the happiness as energy efficiently as possible. In this world, that's not going to be defined, right? Because it's like you need like a really large complex structure, just as you need a whole brain. You can't have one atom that like implements consciousness or anything of really of value. Maybe there's like whole intensities of feeling or something that you unlock only when the system is integrated at a really large scale. Or, just mundanely, if there's just in a much more normal economic sense, you could have, you could have increasing returns to scale because we can just produce more with one big economy than two little ones. What effects does this have? So one is that typically it'll motivate more risk tolerance in investment. So it pushes in the opposite direction from the point I was going on about before with the with the gains from trade. Because you want to make sure you get the whole planet and not just, a 50-50 chance of getting half of one. Or you prefer a 50% chance of getting the whole planet to getting half of one for sure. A second implication is that you might expect the world to be more peaceful in the future. At least according to the liberal peace hypothesis, that there's less conflict between parties that have more to gain from trade with each other. Well, the room for gains from trade will just increase if we can, take better advantage of sort of returns to scale that technology unlocks. Then finally, more generally, there will be even greater potential gains from collaboration than you otherwise would have thought, or than we were talking about before. And so maybe we should invest a lot into looking for that equilibrium that the folk theorem tells us should exist, that exploits it. Anyway, thanks for putting up with that set of thoughts, and I'll just recap the whole 2 weeks. So first, incremental automation of particular tasks and jobs is compatible with all the Caldor facts: constant growth rate, labor share, interest rate, and so on. We're seeing some of that. This time is different if we start seeing interest rates rise, either just mechanically because the marginal product of capital is rising, or in anticipation of that happening, or if we see the capital share rise, or if we see important supply chains automated. There's a lot of things that could be evidence that we're starting to move toward an AK world. We're not really seeing those, but technological advances can take a long time to pay off for various reasons, including because co-investments could be needed or something. We need to build all the wrappers or gather all of the relevant data for different jobs or create the RL environments to automate them. Full automation is feasible in principle, and it must be profitable eventually if there's some cost that could create bots that can do everything people can do. It's just incompatible with a business as usual world where wages rise indefinitely at 2% a year or something, because eventually we'll want to build the bot instead of pay those really high wages. If we automate production, by which I just mean move to a gross substitutes world, then we're basically in a robustly super exponential scenario because it's AK production with A rising. Though technically, this can be stymied by this Baumol effect from new goods, or a big decrease in the savings rate if we have utility that's more CARA and not CRRA. Natural resources could be a bottleneck, but probably only a mild one for a really long time. The natural resource share would have to be way higher than 5% to for the growth rate to not be whatever 1,000% or whatever. Yeah, robust effects on the labor share. Labor share is probably going to fall. Inequality pre-distribution is probably going to rise, but the product of the two, I think, is just kind of ambiguous. For automating R&D, you've got this thing where it could boom or fizzle depending on whether lambda over beta is greater than 1, or it could explode for a while and then fizzle if it kind of runs up against the ceiling. Various bottlenecks to R&D we've seen. Full automation could, super exponential growth is even more robust. And it would arguably be a return to something like the Malthusian past with bots in the place of people. Then moving on to the second week, we learned about the universal approximation theorem, telling us that a big enough AI model trained on enough independent data of our behavior should be able to mimic us perfectly, with the wrinkle that if it's less sample efficient, then for new sorts of things that there isn't much data on yet, people will still be better. Scaling laws tell us how loss falls with model size, data, and then compute, which is going to be growing with the product of model size and data, basically, at least in pre-training. And how if you then make assumptions on how much of those inputs, in a particular compute, you need to get to AGI, then you can model the path from here to there. We heard some bizarre ways that AIs sometimes behave, like learning to be evil from patterns of numbers or learning about owls and stuff. If we think that growth or X risk from AI is coming. Interest rates should be high. It seems like they're not. And in fact, they fall when new models are released. So go figure. Even a small chance of X risk is more important than a lot of growth if we don't discount, and maybe even if we do, according to Chad. But the two things can interact, as I was talking about yesterday. We might be able to lower the risk with some well-applied economic theory or regulation, though we've got to be careful because equilibrium effects are always funky. And more generally, if we're willing to let ourselves think creatively, AI could open all sorts of possibilities for the future. So let's try to make the best of it. Okay, that's my grand recap. And there you go. If you thought you got your money's worth, then let us know.